Right, more quotient rule in dealing with negative exponents. Okay, so let's have a look at this question 31 though. Students seem to forget that an x is an x to the 1, okay, over, x to the 13. If I subtract, I would get x to the minus 12, 1 take away 13. Remember, I would have to change that to 1 over x to the positive 12, okay? That's how you do them. But, you know, I've kind of got away from that, and I just say to my students, look at the problem, where's there more x's? There's definitely more x's on the bottom, so that's where they're going to stay. By how many? Well, turn it upside down if you want to. What's 13 take away 1? 12, okay? So there's more on the bottom by 12. That's why it becomes that. That's what I do. I mean, I don't never think about using negative exponents. I just think, where's there more of them? And that's where they're going to be. Okay. Now then, this next one is a very interesting one because you're going to do this rule soon. All right, look at this. This is a belter, is this one. Right, 2 take away 2 surely is 0. Well, then that's my answer. When you sat going, well, okay, right, is that it? Well, no, because there's a definition coming up here. That's fine, but look. What's anything divided by itself? Anything divided by itself is a 1. Believe it or not, x to the power 0, anything to the power 0 is 1. Just try and get it into your head, but here's the explanation of why. Okay, I never think of it anymore. I just know that anything to the power 0 is a 1. 2 to the power 0 is 1. Y to the power 0 is 1. Okay, now watch a few kind of a bit more complicated ones. All right, because have a look at this. Negative x all to the power 0 is 1, because that is the base. It's all been raised to the power 0, which makes it 1. But this one, okay, let's go back to what's the base and what's the exponent. Here, the base is the x. The exponent is the 0. This is the thing that I'm being raised into the 0, so this is the 1. But don't forget, there's still a negative there, so it's a negative 1. All right, it's not part of the base, it's not negative. I've got to write it in later. Okay, silly things you get like this. What's 3 to the 0 plus 9 to the 0? That is 1 plus 1, which is 2. There you go, the easiest problem in math. What's 1 plus 1? There's a 1, there's a 1, because it's been raised to the power 0. You'll see some things like this on the test. Let's look at something like this. Let's see if I can remember one. Right, 7 to the power 0 over, oh, I don't know, negative 7 to the power 0. Well, that is 1. The bottom is, what's 1 divided by 1? 1. I mean, all these things are to the power 0, so they become 1. So do remember that one, okay? Anything to the power 0 is a 1, but just be careful. What are you raising to a 0? Is there a minus in front? Is it part of the base? So again, remember, negative x all to the 0 is not negative x to the 0. That is 1, that is negative 1, because the negative is not being raised to the 0, okay? So, 2 to the power 0 is 1. Anything to the power 0 is 1. Oh, sorry folks, I just assumed one below. You may get carried away with that rule. I forgot about this one here. Now, this is, again, another visual thing. Now, you can, if you want to, do the subtraction because it's a division. But the easiest thing to do when you get to more complicated problems is always flip the negative exponent to make it positive. The x3 is fine where it is. It is not a negative exponent. But if I put this to the top, remember, flip them. Okay? If it's on the top, put it on the bottom. But if it's on the bottom, put it on the top. Okay? So now I can multiply, so I add the exponents. That is x to the 11. Okay? So remember that. You know, don't make it easy on yourself. That negative 8, it's on the bottom. You put it on the top. It's now a positive 8. I flipped that. I left the x cubed alone. I didn't flip that. It's not a negative exponent. There you go. Just a position thing.